Okay, so it's time for a challenge on autoboxing and unboxing. In this challenge, you'll need to create a simple banking application with a customer and bank type. The customer will have a name and an array list of transactions containing double wrapper elements. A customer's transaction can be a credit, which means a positive amount, or it can be a debit, a negative amount. The bank will have a name and an array list of customers. The bank should add a new customer if they're not yet already in the list. The bank class should allow a customer to add a transaction to an existing customer. This class should also print a statement that includes the customer name and the transaction amounts. This method should use unboxing. Hopefully that's fairly clear, but also gives you a little room to be creative. Alright, so it's your turn to see if you can complete the challenge. Remember, don't overcomplicate things. You should aim to keep it pretty basic. The customer's literally only the name and the transactions at this stage. You don't need to store customer contract addresses or anything like that. The main thing is the relationship between the various classes and also the auto boxing and unboxing. Right, pause the video now. Okay, how'd you get on? Did you figure it out? Let's go through with my own implementation and build this. I've created a new project named Autoboxing Challenge for my solution. For simplicity, I'm going to add our classes in the main.java source file so they won't be public. But if your solution put classes in separate files, that's okay as well. Actually, for customer, I'm going to make that a record and not a class, since there's very little functionality needed. A record customer with the parameters string name and array list of double-called transactions. I'll have a customer record that takes a name and an array list of transactions. It would also be nice to create a new customer with just a customer's name and an initial deposit amount. Like any class, we can create overloaded constructors in a record as long as a call to the default constructor is the first statement. Let me add that constructor. Public customer with name and initial deposit parameters. This name dot to uppercase. New array list of double, passing 500 as the argument. Transactions dot add initial deposit. This constructor takes two arguments, name and a primitive double I've called initial deposit. I first call the record's implicit constructor, passing name, first making it uppercase, and secondly, a new instance of a double array list. Here I'm setting the capacity to 500, which is what I'm estimating will be sufficient for most customers for a year of transactions. Remember, if you can guess the maximum size of your array list, you can set the capacity this way. This prevents the JVM from incremental reallocations as the list grows. After this, we can add the initial deposit to the customer's transaction list, and here I'm using autoboxing, passing a double primitive variable to the add method on array list, which autoboxes it to a double wrapper instance. So that's a pretty simple record. That takes a double primitive argument, then passes that with autoboxing to the add method on transactions. And that's our customer record. Let's try out this record by creating a new customer in the main method. First, I'll create a test customer object and print it out. I'm calling the customer Bob, passing Bob S and $1,000 to the constructor. As you can see, the record prints out the name and transactions of the customer record. Nothing difficult to understand yet. Now I'll create the bank class. As mentioned previously, my solution is putting everything in the one file, main. This time, I'm not going to use a record. I want more functionality and flexibility for the bank, so I'll use a class, class bank. Private string name, private array list of customer called customers, and I'll set it to a new empty array list with a capacity of 5,000, and then a constructor that accepts only a string. This dot name equals name. In this class I have name and an array list of customers. Note the lack of the public access modifier because it's in this file and not a separate one. I initialize the customer list with a capacity of 5,000, assuming a bank could easily have that many customers as an example. And then I set up a simple constructor just with the bank name. Because I don't have getters and setters, no client code can access the customer list, and this is exactly what we want. Before we add a customer, I want to add a method that returns a matching customer from the list based on the customer's name. So first, I'll add this method calling it getCustomer. Private customer getCustomer with a string customer name as the parameter. I'll use an enhanced for loop to search all customers. Have we found a match? return the found customer if so. Not found, so print a message to that effect. Return null. Again, hopefully there's no surprises with this code. I'm using an enhanced for loop, looping through the customer list. I compare the customer name with the name passed as the method's argument, ignoring the case. If I find a match, I return that match immediately, quitting out of the loop and the method at the same time. Otherwise, if we get to the end of the loop, we haven't found a match, I'll print a message and then return null from this method, which indicates no match. Okay, so now it's time for the add new customer method. Public void, add new customer with parameters, string customer name and double initial deposit. Look up customer using getCustomer. If it returns null, meaning a customer was not found, I'll create a new customer object, add it to the array list, then print out a message that it was added successfully. Customer equals new customer, passing customer name and initial deposit as arguments. Customers.add passing the newly created customer, print a message confirming what happened. This code is pretty straightforward, I hope. I take a customer name and an initial deposit amount, then create a new customer record with these values. First I call the getCustomer method, and if it returns null, we know we need to add a new customer. In the case of getting null back, I create a new customer record and then add that to the bank's customer list, and then confirm what happened with a println. At this point, we have a bank class, which we can use to add customers, and a customer record to add transactions. Let's end this video here. In the next video, I'll pick up from here and create an instance of a bank, add a customer, and finish the rest of the bank's methods. I will see you in that next video.